You've verified every physical connection. The cables are intact, terminating resistors measure correctly, yet the control panel flashes a relentless, blinking red bus fault. When a PROFIBUS DP master fails to recognize a slave device, the immediate instinct is to blame the copper wire. We look for short circuits, electromagnetic interference, or degraded connectors. Most of the time, the physical layer is perfectly fine. The actual breakdown is happening entirely in the logic, specifically a misconfigured software blueprint known as the GSD file. Industrial hardware, like these ABB soft starters, relies on precise commands to manage heavy electrical loads safely. That capability is inaccessible if the master controller cannot understand the specific language of the device. The General Station Description, or GSD, is a mandatory ASCII text file. It defines the hardware's internal register structure and electrical tolerances, providing the network logic with a precise map of the physical station's capabilities. To resolve these handshake failures, we need to read the GSD architecture directly. We are going to deconstruct the file and isolate the precise memory mappings and timing parameters required for deterministic data exchange. Physical robustness cannot compensate for a broken digital identity. Mastering the ASCII GSD file is the absolute requirement for reliable interoperability on factory floors. Before a master controller can send a single voltage pulse to a slave, it has to successfully parse this configuration file. Every valid file begins with the hash PROFIBUS DP header. This exact line establishes the base protocol before the compiler executes subsequent logic. Right below the header is the ident number. This string of alphanumeric text, such as ACRO06F3, designates the vendor and the exact device model. This identifier is the primary gatekeeper. During the initial power-up sequence, the PLC processor queries the network. If the physical device returns an identity that does not perfectly match the string defined in the GSD, the handshake terminates immediately. While modern hybrid environments frequently use XML-based GSDML files, this foundational ASCII architecture still dictates the core stability of legacy DP networks. Further down the file, the text breaks into modular keywords. These keywords compartmentalize the slave device's internal operations into readable digital blocks. The first level of organization is the slot. Represented by values ranging from 0 to 254, a slot corresponds to a distinct physical module or a specific software function block on the hardware. Inside each slot is the index. The index pinpoints the precise memory address of an individual parameter within that designated modular block. This strict slot and index hierarchy maps exactly to the PLC's I/O memory. The controller uses this grid to determine precisely where to route outbound commands and where to look for inbound sensor data. When a network fault occurs, reading these raw hex codes directly from the configuration allows engineers to bypass generic software error messages and locate the exact misconfigured register. A perfectly mapped keyword structure ensures the master controller never sends an electrical signal to a dead address. A functioning PROFIBUS network operates at extremely high speeds, routing continuous streams of electrical data down a single linear pathway. Keeping those data packets from colliding requires strict adherence to rigid timing constants, measured down to the microsecond. The baseline measurement for network timing is the bus cycle, represented as TBC. This is the total time required to service every active node on the network. Within that cycle, the network relies on sync time, or T-sync. T-sync acts as a mandatory buffer. It forces the bus into an idle state for exactly 33 bit times before any station is allowed to accept a new request telegram. Once the request is received, the physical device must reply. This speed limit is governed by the slave reaction time, or TSDR. The minimum response time is configured at startup. The maximum allowable TSDR, however, scales with the network spot rate, typically ranging from 11 up to 255 bit times, and must be explicitly defined within the GSD code. If a slave processes data too slowly and breaches that maximum TSDR limit, the master assumes the device is dead. This creates digital collisions with overlapping packets or outright timeout errors. Engineers can manually adjust these TSDR limits in the configuration to account for slower legacy devices, preventing jitter during high-speed deterministic polling. Setting these values requires tight arithmetic. The TSYN buffer and TSDR response windows must fit perfectly within the tolerances of the master's overarching watchdog timers. Dialing in these parameters maintains rapid network responsiveness while ensuring the physical copper wire retains its immunity to electrical noise. The capabilities listed in the GSD must also reflect the physical reality of the installation. High baud rates require shorter cable runs and carefully calculated repeater latency. For high bandwidth applications, specific timing limits like max TSDR, 1.5 meg, are declared directly in the text to set hard boundaries on reaction times at 1.5 megabaud. The GSD file acts as the ultimate governor of the physical layer, dictating the exact microsecond tolerances that the electrical signals must obey. The cyclic data streams we've discussed are highly efficient for continuous, basic input and output operations, but complex industrial equipment, such as motor management controllers, require instruction sets that are too dense for standard cyclic polling. To handle this, PROFIBUS utilizes the MS2 channel to transmit acyclic data. These are dense, irregular clusters of data, sent only when specifically requested. Inside these acyclic bursts is the PKW exchange, parameter, Kennung, Wert. This handles the heavy lifting of reading and writing complex device parameters. The GSD file allocates memory for these operations using specific keywords, namely user prom data and ext user prom data ref. By incorporating these text blocks into the configuration, the system gains direct access to specialized registers and functions otherwise hidden from standard cyclic polling. Instead of just turning a motor on or off, the master can now define precise acceleration ramps, set specific overload thresholds, or switch the module entirely between local and remote configuration modes. Accessing these features requires strict version control. The internal logic declared in the GSD must exactly match the physical firmware installed on the slave device. If an engineer loads a GSD for version 2.0, but the hardware is running version 1.0, the acyclic burst will attempt to write to memory registers that do not physically exist, triggering an immediate bus halt. With correctly mapped parameter data, a simple I/O node functions as an intelligent, parameterizable station capable of local logic execution and advanced diagnostics. This technical diagram illustrates the shift from legacy 4 to 20 mA analog wiring to a device-neutral profile GSD architecture, connecting hardware like flow meters and positioners directly to the central system. The entire deterministic pipeline relies on 3 engineering steps: verifying the identity keywords, tuning the TSDR timing constants, and mapping the acyclic parameter blocks. True interoperability is achieved only when this validated file compiles successfully in the engineering tool, resulting in a stable green light status across the entire bus length. Because high-traffic acyclic bursts can strain the network, engineers should proactively run diagnostic checks under peak load to guarantee those timing limits hold firm. Any manual edits made to the ASCII text to force multi-vendor compatibility must be rigorously documented. Preserving the exact logic behind those changes ensures long-term uptime on the factory floor.
Thanks for watching. Please visit the channel for more content and don't forget to subscribe and like if it was helpful. Comment if something is wrong.